Okay, so welcome to my game development workshop. So in this workshop, I'm gonna explain singletons. I'm gonna explain objects pooling, just a high level explanation of them. Then I have a prototype for objects pooling where I'm gonna walk through the code and how to use the objects pooling template and put it into your projects. And the objects pool is also a singleton, so I'll be able to go through both concepts in the prototype. And let me show you the prototype very quickly. So it's just a shooter. You can create, the bullets are objects pooled, and then when you shoot, the bullets are taken out of the objects pool and then used. And then once the bullets are done, they're returned to the pool. And if you ever use up all of the objects pooled bullets, new ones will be created. These are the clones, and then they're instantiated at runtime, and they're gonna be destroyed during runtime as well. So so after the singletons and objects pooling, I'm going to go over ML agents, and just for the sake of time, I'm going to flip the order in which I present. I'm going to go through the final results first. I'm going to show you the entirely built agents. Let me just, okay, the mic is working. Uh, I'm gonna go through the final results, just the agents completely trained and the environment completely built, and now I'm gonna show you some examples of what people can add to the environment to make it more complex. You can add obstacle zombies, maybe a gun, and then I'm gonna show you how to train the agents with ML agents using reinforcement learning or imitation learning, and then I'm gonna walk through the code, and after that, the workshop is done. So if anybody shows up to the workshop, I'll be able to walk them through the process of adding objects pooling into adding objects pooling or ML agents into a complete project. But I guess for now it'll just be me, so I can probably skip this step. Okay, so for singletons, what is a singleton? So a singleton is a globally accessible class with a single instance in the scene, and other scripts can access the singleton via a static reference. So uh, you use a single. So let's say you have a game manager, right? And then the game manager manages your game. It keeps track of the zombie spawn rate or like enemy spawn rate. It keeps track of item drop chance. It keeps track of the difficulty, maybe the timer for how long the player has been playing. So all of those variables, they should only exist once, and you probably need to access those variables throughout your program. So whenever you have something like that, something that you need to access globally and something that you should only have one instance of, you can make that into a singleton. Uh, the benefits of singleton is that they're very simple and easy to use, and they allow other parts of the program to easily access data stored in the singleton. So so for the drawbacks of singleton, so like singletons, they're very convenient, but there are a lot of drawbacks. And most of it is just the overuse of singleton. So whenever you use a singleton, uh, because you can access them anywhere in your program, when you change the singleton, you're gonna have to go throughout your entire program and update every time you use that singleton. Um, And I guess if it's the simple projects and you're the only one working on it, it's not a big deal. But if you're working in a team for much bigger projects, that can get very complicated and tedious. Another drawback of singletons is that they hide dependencies within code, making it much harder to understand the dependencies of the class just by looking at its interface. So what that means is that when you have a singleton, so back to the game manager example, if the game manager wasn't a singleton and you want to use it in your player class, you're gonna probably have a member variable, game object, game manager member variable, and that's how you access the data inside that game manager. Or you have a function and you pass in the game manager as a parameter. But then when you have a singleton, you don't have to do that, and you can just access it directly statically. And if somebody else is looking at your interface or your UML diagram, they're not going to be able to understand why this script is able to access these data, or it would just be much harder to draw that connection. And if you have multiple singletons and just very complex dependencies, it will be very difficult for somebody else to understand your code, and that makes your code much much less clear and much harder to maintain. Um, One more drawback of Singleton is that let's say you have a player class and like right now it's a single player game, so you only need one instance of it. So you make it into a singleton, uh, but then later on you decide that you want to add in multiple players. It Because by the definition of a singleton, you're not able to create multiple instances of player, and to implement that new feature of multiple players, you're gonna have to remove the singleton element of that player class. So you have to do a lot of changes. So whenever you're making a singleton, just make sure that um, you're not going to create multiple instances of that objects of that class in the future. So here's a simple code example of singletons. And over here there's a class, it's a singleton example class, and then it has a static variable singleton, a static variable of the class named instance, and this gives you so that's a static reference to itself so that you can access it statically, and then that makes it globally accessible. And then in the awake function, um, the if statement just makes sure that you don't have another instance already created, and if that instance is not this, you're gonna destroy the new instance that was created. Otherwise, you're gonna set the newly created instance as the static reference. So that's singleton. And then for objects pooling, so what is objects pooling? Objects pooling is a performance optimization technique where all objects are created during initialization rather than at runtime. These pre-created objects are kept in a pool and reused whenever needed, eliminating the overhead of object creation and destruction during program execution. So what that means is that when you're using objects pooling, you're basically just creating all of your objects at the start of the program. So if you have a game where you're shooting a lot of guns, you're creating a lot of bullets and destroying them, instead of um, creating and destroying them during runtime, you create a lot of bullets at the start of the program, you pull them together, you hide them, and then whenever your player shoots a bullet, you take that bullet out of the pool and then set it up properly so that it shoots out, and then when that bullet is done, you return it back to the pool instead of destroying it, and that would cut out the object creation and destruction, making your game perform better. So the benefits: consistent performance, and your memory usage is predictable, and it will also boost your performance. So some drawbacks of objects pooling is that you're layering on already managed memory. So C# already has algorithms that optimize how memory is used, and you're just adding another optimization, another layer on top of that with objects pooling. It's totally fine. It's not a big deal. It is going to improve it. So another drawback is that you can't just objects pool any objects you like. You have to write some code to, you probably have to implement a reset function and a setup function just so that when you get the objects out of the pool, you set up the objects properly so that it can be used. And then when you return it back to the pool, you have a reset function that resets it back to default state. Or else like you might have some junk data in your bullet from the last time it was used, and then when you use it again, there could be like unintended side effects. So that's something to watch out for. Um, all right, so we're ready for the objects pooling prototype. So there is a singleton template that you can just copy into your projects. There's a objects pooling template that you can just copy into your projects as well. Uh, Here is the objects pool prototype. So let me just show you the prototype first. So there's a character, you can move it around with WASD, and then there's a gun that rotates to your mouse, and then when you click on your mouse button, your left mouse button is gonna create a bullet. Well, in this case, not creating a bullet, is pulling the bullet out of the pool, and then um, and then setting it up, and then it shoots out. And then once the bullet is done, it's pulled back into the objects pool list. So let me open up the scripts. So for me to set up this prototype, really, I just copy in the singleton class from the Google Slides. I copy in the objects pool class from the Google Slides, and that's what I have to do in terms of code for these two things. And then I built the player class. So let me go through the player class very quickly. So um, okay, so the player has movement speed, has a gun, bullet prefab, bullet spawn point, and then shoots cooldown. So there's a movement function that basically takes in the WASD inputs, and then it calculates the change vector to apply onto the character. And then there's a rotation function that calculates the angle that's created from the vector that goes from the the player to the mouse position, and then applies that rotation onto the gun. That's why it rotates with your mouse. And then there's one more function that takes the input of your left mouse button. So when you click on that, it's gonna somehow create a bullet either from the pool or create a new one, and then you'll be able to shoot your gun, and then timer logic that counts down your shoot cooldown so that you can just create infinite amount of bullets. And then I have a bullet class that moves the bullet, make sure to see lifetime. So like the bullets are, do they die eventually? They don't just stick around forever. Yeah, pretty simple. But I do have a setup function and a handle destruction function. So setup function just resets the position, Euler angles, life timer. Just make sure that the bullet is in a state where it is doing what it is expected to do. It doesn't all of the jump data from the last usage of this bullet is overwritten. And then in the handle destruction, right now I'm just pulling it back into the pool. Let me actually go over the code for a singleton objects pool as well. So singleton, so this is the advanced singleton, is a class that you can just inherit from for all of your singletons, and it's going to handle making it globally accessible and also making it so that there's only one instance of it. Yes, and actually make sure that every time you're trying to access the instance, if the instance doesn't exist, it's gonna search for it's gonna try to find one of that instance if it exists in the scene. If that doesn't exist, it's gonna create a new one and then return it. So it ensures that you always have an instance to use. And then the awake is very similar to just a simple singleton. It just, if there isn't an instance, it just sets the instance to itself, and then it makes it don't destroy on load so that it persists throughout scene changes. And then otherwise, if the instance already exists, it'll just destroy the newly created instance. So that's the singleton. And then for objects pooling, so the way this objects pool works is that in the Unity editor, so right here, this objects pool allows you to objects pool multiple different objects, and you just add them to the objects list. And then for each of the objects you add here, you just have to specify the amounts of that objects to create at the start of the program, basically to objects pool. And right now I have bullet in here, and I'm gonna objects pool 30 of it. And then there's really three functions. There's a setup function, which you have to call somewhere. You have to call maybe in your game manager. Right now, I'm calling it in the player start function. So, yes, and that's good enough for this prototype. And then when you're trying to get objects out of the pool, you use pull objects. If you're trying to put objects back into pool, it's going to do pull objects. So let's talk about some of the edge cases. So when you're pulling objects out of the pool, if the object does not, well, okay, so if the objects is not an object as objects pool, well, what you pass in first is the name of the objects. So if the name of the object does not exist in the objects list, it's going to return null. If it does exist, then it's going to check whether or not there's a objects pool objects in the objects pool list ready to be used. If there is, it's gonna take that one out and then return it. If there isn't one, then it's gonna create a new object, and this object is gonna just work like instantiated objects. It's not object spooled, so it's created at runtime, and then when it is to be destroyed at the end, it's gonna be it's gonna just be destroyed. It's not gonna be put back into the pool. Um, if you want new if you want newly created objects to be put back in the pool, you have to update the code a little bit, or just create more objects at the start of the program. So for the pool objects, it so that's adding objects back into the pool. So first it checks if the object is something that is specified to be objects pooled. If not, it just destroys it. If it is, then it puts it into a pool. Mhm. Yeah, so very simple. And let me see. Oh, one more thing that I need to talk about. So right now I'm gonna just get rid of the objects pool for now. So normally without objects pooling, you're gonna just instantiate your bullet, right? Just like this. And then same thing for destroying. You're gonna just destroy it instead of putting it into the objects pool. So normally you're um so this is what it looks like normally without objects pooling. You know, when you shoot, you create a bullet, and then the bullets are just destroyed once they're done. And when you add in objects pooling, you do it like this. Instead of instantiating a bullet's prefab, you're gonna grab it out of the pool, and then you pass in the name of the prefab that you want to create. And then you have to call a setup function. You have to implement a setup function for every objects pooled, for every object that you want to objects pool. Mm-hmm. And then the same idea for destroying the objects. You have to implement some sorts of reset function. In this case, there's nothing for me to reset, but um, it's still something to watch out for more complex objects. But let me turn this back on. So now instead of destroying the objects, we're going to put it into the pool. So as you can see, the difference is that, let me actually decrease the number of bullets so that it's more visible. So instead of 30, it's going to be 10. So as you can see, like the bullets are coming out of this list here. And then um, the more if you're using more bullets than the ones in the objects pooled list, it's going to create a new one, and those new ones, the clones, are going to be destroyed once they're done. So that's objects pooling. I think it's still just me right now. Yeah, I guess we're ready for ML agents. Let me see. Yeah, so for ML agents, I'm gonna swap the order. So I'm gonna show the final results first, and then I'm gonna show you how to train it, and then I'm gonna walk through the code, and then I'll be done with this workshop. So let me show you the final results. For the prototype, uh, yeah, so that's my agent. So the way this environment works is that, you know, this blue ball, that's the agents, and then his goal is to collect the purple ball, and then he is confined inside these walls. So that's his environment. If he hits one of the wall, he's gonna die. And then there's also a timer for every run. He only has 15 seconds to collect all of the food, and if he run out of time, he's gonna get punished. If he hits the wall, he's gonna get punished. Every time he collects the food, he gets rewarded. If he collects all the food, he gets a bonus amount, and that's how the agent knows that his goal is to get food and then try to avoid the wall, try to get the food in a fast enough amounts of time. And right now he's basically perfect. I don't think he'll ever mess up. But this is also a really simple environment. So and you might be thinking that it's probably you'll probably just be able to code the behavior and have a much better agent anyways. But you can add more you can complicate this environment by adding more things to it, maybe adding obstacles, zombies, or even a gun, and that would make the agents much harder to code. And the more you complicate the environment, the more it makes sense to use ML agents. And when you're learning ML agents, it's definitely best to start with a very simple environment, uh, something that you wouldn't even need ML agents for. So let me show you what you can add to this prototype to make it more complex. So in this one, I added obstacles. I also added zombies that chase the agents down, and then you see that the agent learns to kind of like go around them, try to avoid them, and then it will also go around the obstacles. Sometimes he still gets left behind the obstacles, um, but I guess the zombies they kind of chase him out of it. So you know, and the longer you train them for, usually the better they get. So here's another one, another iteration. So on top of the obstacles and zombies, I added a gun, so now he can shoot the zombies, and yeah, and his goal is to still collect pellets. And I think in this case, I actually had two brains. So I had a brain for moving the agents, and then another brain for shooting the gun. So I was able to train them separately. Mm, yeah, so and you can add more things to this prototype, or you can create a completely different environment and try to train the ML agent. So that's the end results. Mm, yeah, I guess let me walk through like some of his observations and things like that before I start training him. So like right now for this agent, he has let me see. So it has two sets of sensors. So there's a wall sensor, this is a red one. There's like 10 rays, and then it goes 180 degree. Well, it's 360-degree. And then, yeah, it just detects the walls and make sure that the agent avoids the walls. And then a food sensor that specifically sensors the food. Uh, yeah, that's pretty much it for the sensors. I guess let's train the agents. I'm gonna show you just reinforcement learning by itself, and then I'm gonna show you imitation learning, and and for the second part, it's really imitation learning combined with reinforcement learning, and you'll see that you get much better results from the second one. So let me go to it. So for training, um, I have the projects here. Let me get rid of the model and then turn it to default. And I'll explain what all of these are after I've trained the agents and I'm going through the code and setting up the agents and the environment. So let me see. Yeah, let me just apply it to all. So I'll be able to open up all of these environments as well and train the agents much faster. So when you're trying to train your agents, here's what you need to do. First, open up your projects. I have it in the ML agents collector. You open it up, and then when you see all of your folders, your assets folders, your library logs, this is where you open up the CMD, and then you go into your. Oh yeah, I have to set up the virtual environment. I I guess I can show you guys. I'll show you guys how to set up the virtual environment afterwards, because we're going backwards right now. Scripts, activate. So you're activating your virtual environment, and then what you're gonna do is ML agents learn run id equals So all of your training, they're gonna go into this results folder, and then so these are my previous runs. Let me just delete them. I'm gonna start the training from scratch. So I'm gonna start from run one, and right now this is just reinforcement learning. Give it a second. Okay, and now you're ready to train it. Yeah, so right now the agent is just performing his actions randomly, and it's trying to, and then it's being punished and rewarded based on the results that it is getting, and like eventually it will see patterns and know which action will lead to better rewards, which actions will lead to punishments, and then it will just be able to do the task that you want it to do. And let me open up all the other environments as well so that we can train this much faster. I'm probably just gonna train this for like 5 minutes. So I'm gonna stop this at 3:12:32. So yeah, like the agent's already uh he's kind of going for the pellets. He's kind of going for the food. Let me just see if anybody joined the lecture. Okay. Yeah, so now he's going for the food. So we can stop. Oh, and you see like his mean reward. So you can see like right now the agent is getting better. He's still in the negative, so uh, he is still not completing the task yet. But he'll slowly get there. It'll just take some time. And when you're just doing purely reinforcement learning, it's gonna take a while. And the more complicated the environment, the longer it's gonna take. So like 2 more minutes, and then we're just gonna stop this and then go to imitation learning with combined with reinforcement learning, and we'll get much faster and better results. Let me see the results. So yeah, as you can see, he's getting better and better. So still in the negative. But yeah, usually when you're training your agent, you kind of just you just leave it there for like an hour. Maybe for like simple environments, you let it train for 10 minutes and then you come back. But for more complex environments, you probably leave it there for like an hour or even like 5 hours a day, depending on how complex your environment is. But yeah, it's 12:32, so let's end it. No, and I'll show you how to get the model into your project so that you can use it for your game. So you go to your file system, you go to the results. So it's run one, and then oh, we have to end the run. So Control C, that ends it, and then it copies the Onyx file to the folder. And the Onyx file, that's basically the brain. So copy this, and then go to your assets, and then this is where your projects is of your assets, and you just paste it in. Oh, I guess that's the collector from before. Let's rename it to like perfect collector, and then I guess we can paste it in now. So this is the collector that was just trained. So let's rename it to uh, RO collector. So this is a reinforcement learning collector. So we put this in, we put it to inference only, and then we can look at how it performs. So yeah, he's kind of going for the food, but not really. Yeah, he's going for it. It's just he's struggling to make that decision. He's still there's still some randomness to it. That's why he's um jiggling around. Yeah, and then he essentially just runs out of time or runs into the wall. But if you train him for like maybe an hour, he's probably gonna be able to complete the task and collect all the food. Yeah, hit the wall. Yeah. Okay, so let's move on to the next training technique. So we're gonna use imitation learning. Oh yeah, I didn't even explain what reinforcement learning was. Yeah, well, reinforcement learning is just do I have it written anywhere? Oh, okay. I didn't have that written anywhere. So, but reinforcement learning is just that you have an environment, you have the punishments and rewards specified, and then so like in this environment, I'm gonna just repeat myself. Um, the agent, when the agent collects a food, he gets a small reward. He gets a reward of 10, and then when the agent collects all of the food, he gets a reward of 100, and that's added to uh, the reward for getting each of the food. And then for the punishments, so when he hits the wall, he's gonna get punished for negative 100. If he runs out of time, he's gonna get punished for negative 100. So right now I have the punishments as the same value, just so that um like so if you have sometimes when you have a very harsh punishment and another punishment that's not as harsh. So let's say I make hitting the wall or like running out of time negative 200 and then hitting the wall negative 100, and then the Asian the Asian his goal is just trying to maximize the reward and punishment. Um, he's not it's not like this is a negative reward, this is a punishment, then I'm gonna avoid it. It's more like uh, if this will lead to a higher value, then I'm gonna go for this direction. So let's say you're Asian, um, you just started training the Asian, and then it's always running out of time, so it's always getting punished for negative 200. Then it hits the wall, and then it gets punished for only negative 100. Then it will see the pattern where if it hits the wall, it gets a lower punishment, and then it's gonna start hitting the wall again and again, and then at a certain point, it might just get stuck doing that, and it won't make any improvements. So that's why usually I just have the punishments as the same value. Yeah, that's something to watch out for. You can definitely make the punishment different values, so that there's an emphasis on avoiding the wall, or avoiding running out of time, depending on which one's more important. But let's do reinforcement, imitation learning now. So the way imitation learning works is that you need somebody to provide training data. So you probably just turn on record, and then you play the game and try to collect all of the food, and then all of your decisions and all of the decisions that you decide to make and the observations that the agent is seeing at that time will be recorded, and then those data will be used to train the agents. And if you play the game properly, if you play well, you'll be able to train your agents much faster. So let's do that right now. So first, I'm gonna go to my agents right here, demonstration recorder. I'm gonna turn on record. So now it is gonna record the the decisions that's made to this agent, either by me or by any. It's gonna be by the his heuristic function. So let me go to here. Let me get rid of the brain to 9, and then to default, and then um, and also you're gonna need a configuration file. So I already have it. It's gonna be a YAML file, and the contents of the file is in the Google Slides. But yeah, it's basically going to, you're really just adding this part where uh, it is using the demo video or demo data to train the agents. Let me get rid of the previous demo if there is one. Yeah, there's a previous demo, so let me just delete that. So I have record on. I'm gonna start the game, and then all of the actions that I make will be recorded, and then there's gonna be a file that's generated here for the demo. So let's go. So I'm gonna go for like probably 20 episodes, and then we're gonna do imitation learning. Alright. So right now it's just and like perfect score would be, oh yeah, and there's one more thing I forgot about the reward. So when the agent collects all of the pellets, he's gonna get a reward of 100. In addition to that, he's gonna get a reward equal to the remaining time that he has. So he has 15 seconds to collect all the pellets. When he collects all the pellets, if he has like 10 seconds remaining, that 10 is added to his total reward. So the highest possible score is like 215 if he collects all of the pellets in 0 seconds, which is actually not possible. I guess like it takes around 5 seconds to collect all the pellets. So like if the agent reaches a mean reward of 210, that means he's basically perfect. Yeah, that's 20. Let me finish this one, and then we're gonna do imitation learning. So yeah, that's done, and then I'm gonna turn off the record, and over here, ML agents learn configs imitation. So when you're training your agent, you can specify a YAML file, and then it's basically like configuration for your training. And then I'm gonna do run. Let's make it run too. And like as you can see, the demo video is generated. This is a new one. Okay. So right now it's still random, but it is training. It is basically trying to imitate you as a player, the demo that was provided, and it will get better very quickly. Like yeah, like it's big. That's it. It ran out of time, but it almost got off the food right there. And like right now, I only have one environment on, so and it's already almost able to complete the task. So imitation learning is very helpful. Okay, I think it got it. So that was the first time it got off the food. It still goes into wall, but we just needed to train for a little bit more. Yeah, and now like it basically got a perfect score right here and here. 208. Yeah. Yeah, this is really good. And usually what I like to do is um let me stop this right now and then so after doing imitation learning, I'm gonna use the configuration file to train it inside so that it's doing reinforcement learning. And this way, um, if there's any junk data inside the imitation in the demo in the demo data, it will be able to if you're doing you go back to reinforcement learning, you'll be able to bypass that and get an agent that's better than your than the demo data that's provided. So we're gonna keep it run 2 and then we're gonna do configuration.yml and then we're going to resume. Started. So now it's just doing pure reinforcement learning. Yeah, that's the error, but no, it's something with the food. Like I guess like the food is spawned and then it was spawned right on top of the agent and then it causes a error here, but it's nothing game breaking. But yeah, we trained this for like 1 or 2 minutes and then we're probably gonna have it perfect spots. So while it is training, let me look at what I still have to go over. Okay, so yeah, so after the training is done, I'm gonna get the model out, put it into the projects, and then after that I'm gonna walk through the code, and then after that I'll be done with this workshop. Yeah, let me just open all of these. I forgot to activate all of these. Yeah, it's only 100. I guess like once in a while it fails, and then that brings down the average. But yeah, like if you look at here, it's getting to time basically. It's basically perfect. 180, yeah. So like the next time, the next um, the next message is probably gonna just be 2 time or very close to it. You're still messing up once in a while, but the more you're training, the better it will be. But that was much faster than just pure reinforcement learning. So it's always a good idea to do some imitation learning at the start, and then at a certain point swap back to reinforcement learning. Yeah, the imitation learning basically gives your agent a jump start. It's still messing up once in a while, but yeah, 201. I think this is good enough. Let me go through the code so that I can get this done before 1. So, um, and then let me just show you again how to get the model into your projects. So you go to the results folder and then run to collector, copy it, and then go to your assets folder and just paste it in. So this is imitation, imitation plus or up. So let's put this one in. I guess you can also see them side by side. So I can open this one up and then put in the previous one. Wait, give me a second. Okay, so I'm back. Yeah, so this one, let's put in just a purely reinforcement learning, and then let's open up one more for the perfects collector. So like, this one, wait, is this one the perfects one? Yeah, this one's the perfects one. This one is the one that we just trained, and then this one is the just reinforcement learning for like 5 minutes. So of course it's not going to be really good. But yeah, let me go through the code now. Okay, so this is my agents. You're gonna have to inherit from the agent class, and then you use these libraries, ML agents, and then you do the actuators and sensors. So you're gonna have to override a few functions from the agents class. I think it's these 5. So there's initialize on episode begin, collects observations on action received, and heuristics. So initialization, that's just like this basically replaces your awake function. And then on episode begin, so every time the agent like completes a task or dies, uh, you re you restart the episode. So the episode is just like one run. And then So like this is you just set up. So on in this function, you just set up the agents, reset the environment, put the agent at a random position, and yeah, that's all you do for this function. And then for collects observations, so a lot of observations would just be sensors on your agents. So these are the ray perception sensors 2D. So these are the sensors for the agents. But then you can also add in other observations for the agents, and then over here I added in the local position the of the agents. Um, it's also important to just use local position because you're gonna make copies of the environment, and then if you're using the global position, that's not gonna work because you're gonna have everything spawn like the original environment. So on action received, so this is like this is the logic for updating your agents depending on the inputs that it received. So if you're pressing like WSAD, it moves the agents, you know, it updates the position of the agents, and then I guess that's all you can do for this agents. And it's overwritten to a point where it can take input from the heuristic, or it can take input from the model. So the heuristic function is just um, is is to be provided by you the user, or by a perfect spot that you create. So if you're testing out your agents, you can put in inputs for you to put in, and then convert it into actions to be passed out, and then these actions will be received by on action received, which is then applied to which is then used to perform the logic of your agents, updating its position, other things like that. And then these collisions here, these are just rewards and punishment depending on what the agent collided with. If it collided with a wall, punish the agents and end the episode. If the agent collided with a food, reward the agents. If the agent collected all of the food, um, reward give him a lot of reward, and then give the remaining time of the episode as a reward to the agent as well, and then end the episode. And if you ran out of time, punish the agents. Yeah. And then I just have a class here for the ML environment just to spawn the food, get the random positions, set up the environment so that the agents can train properly. So pretty simple. Yeah, I guess that's it for the code. I guess that's it for the workshop. All right, bye.